Hello. Today's session is about two problems. 35 about two interacting wires where the currents may be in the same direction or in the opposite direction, and thus they may repel or attract. And then we will see Ampere's law applied in problem 43. Let's start with a quick summary. For two parallel wires, and we have the current going upward in both. So think about the magnetic field created by one wire on the other. ما حدا بيقدر يعمل magnetic field على حاله، اوكي؟ سو مثل الدفاية بالشابتر 22، الدفاية بتدفي حدا بس ما فينا ندفي على حالنا، لأنه if you look at the Biot-Savart's formula في بقلبها بالدينومينيتور في عنا r squared. So r is different than zero. ما حدا بيقدر يعمل magnetic field على حاله. So مثلا إذا عم بحكي عن الكيرنت الأخضر it should make a magnetic field على الأحمر. So place your thumb on the green wire, okay, and your fingers on the red, الcurved fingers on the red. okay, رح يكون point البي الأخضر رح يكون point. So على الأحمر حنرسم بي أخضر جاية من ال I2. It's a point pointing outward out of the page. If you repeat the same for magnetic field created by I1 on I2, so you put your thumb on I1 والمagnetic field اللي عم يبرم حواليه لل I1 رح يكون going into the page على البوزيشن تبع الجرين. So the magnetic field turning around the current 1 is going into the page on the right side of the I1. That's why البي الأحمر هو على الجرين. And if you think about the source of the magnetic field الجرين هو حيكون current in green كمان. Okay? So if you put your thumb on I2 going up, على left side your fingers are going towards you. So لازم يكون point. هلا what is the force since عندي current وعندي B at the same time, okay, and they are interacting with each other لأنه عاملين a certain angle, so حيكون عندي mechanical force F. اوكي أنا سميتها mechanical لأنه هو شيء الفورس دايما هي شيء mechanical, بس actually it is created by the current and the magnetic field. So بتتذكروا الفورمولا تبع الفورس magnetic هي IL cross B, which is ILB sine theta, and the angle between the current and B is 90 degrees, so هي ILB. Now use the three fingers, the right hand rule تبع chapter 28. If you put your thumb with I2, for example, the B هي cross into the page, the force would be on the left. The all fingers will be on the left. Now if you think about I1, كمان going up, but B is pointing to yourself, so F will be going to the right. Your hand is a little bit twisted. هلا مزبوط الفورس هي ILB واتفقنا الانجل is 90, بس ال B itself is induced by a wire والstraight wire formula of B induced هي mu 0 I over 2 pi D. هلا في عندي current I عم بيعمل interaction مع magnetic field جاي من ال 2, so رح يبين عندي ال current 1 and 2. So إذا بتقلبوا الفورمولا إذا بدكم تجيبوا ال F2 ما رح تفرق شيء لأنه same length, same distance separating the two wires, same constant mu 0 over 2 pi. وإذا عملنا I1 times I2 ولا I2 times I1 ما فرقت. That's why I can say إنه ال attraction هي ذاتها same force magnitude F1 and F2. So we already saw that if the currents are going with the same direction رح يعملوا attraction. حتشوفوا two currents عم بيقربوا على بعض. two wires بلشوا يعملوا attraction لبعض كأنهم magnets. إذا كانوا الماجنتس إذا كان الكيرنتس in opposite direction in each wire مثل ما هلا رح نشوف أكيد you expect that they would repel each other. So let's prove it and find the magnitude again. So what do you think? The magnetic field is going how on each wire? Use the curved fingers rule with your hand, right hand. So if you put your thumb with I1 على right side of I1 the magnetic field is going into the page, so بحط X. If you put your thumb على الجرين I2 is going down, كمان حتكون X on the right side of I2, so the magnetic field 2 is going into the page as well. Now think about the direction of the force. So, for example, if I am thinking about the green I2, I have to use B1. So I2 is going down, you put the thumb down. B is going into the page, the force is going to the right. If you think about I1, you put I1, the thumb is going up, you put the index going into the page لأنه هي representing B, and the whole fingers would be going to the left على current I1. So the force على 1 is going to the left. This means the two wires are repelling each other. Again, put a pause. Please think about the direction of the force on your own. Never rely on what I am saying. Please always check the answer and try to solve the problem on your own. Again, if you find the force in magnitude, you will find the same F mu 0 over 2 pi I1 I2 L over D. Since we are well prepared and we already treated the cases of the two wires, from the summary you know that when the currents are opposing each other, they are repelling each other. So the force is known الدايركشن تبعيتها بس هن they focused on the x component of the magnetic force per unit length of the wire 2 on the wire 2 due to wire 1. Okay, so أنا بدي أرسم الفورس only on 2. هلا maybe you can draw both at the beginning بس at the end I'm only interested in the x components of F created on wire 2. وشو معناتها هيدي per unit length؟ يعني you can take L as 1 meter أو بتجيبوا الفراكشن F over L. يعني لأنه ال L is not given so it's easier. اوكي هلا المagnetic field هو tangent to the circle يعني perpendicular to the radius so ال B is perpendicular to the radius من السبب للنتيجة اللي هي direction dotted line اللي شايفينها قدامكم. هلا كيف بدي أعرف إذا tangent up or tangent down؟ you use the curved fingers right hand rule. So you put مش ال three fingers the curved fingers. So you put for example if you are focusing on the current 2 and you draw your fingers turning around I2, okay, the thumb is going into the page, your fingers are turning tangent to the circle يعني perpendicular to the radius up. That's why B2 is marked up. Again, if you take if you do the right hand rule تبع curved fingers بتحطوا ال one pointing to yourself لأنه الكيرنت جاي صوبكم and then the curves of your fingers is going كمان up so B1 is going up perpendicular to the radius اللي هو distance between 1 and 2. Now, once you know the direction of the magnetic field, it is easy to use the right-hand rule تبع ال three fingers to find the direction of F. For example, for the first current, you point to yourself with your thumb, you point in the direction of B2 with your index, so the other fingers are going with F1. Again, if you put your thumb into the page as in current 2 and the magnetic field going with the vector B1, the force F2 is going down. So perpendicular to B1 and the current 2. Now to find the magnitude of F, it is ILB sine the angle between the current and the magnetic field, which is here 90 degrees. So since B is induced, we already explained that. You replace it by mu 0 I over 2 pi d. And you can find the F over L. You take L to the other side of the equation. And you know that F1 is equals to F2 in magnitude because they are two interacting wires. Since we are asked only to find the x component of F2 per unit length, so I'm not interested in F1. I'm only interested and focusing on F2. So the x component of F2 per unit length يعني هي F2x per L is equals to F2 times cosine theta and theta is shown in the figure. هلا theta of F2 هي ذاتها theta in the blue triangle لأنه direction of F2 هي ذات الdiagonal تبع ال D ال D in red. Now اللي هي 5.4546 centimeters. Anyway, Z direction, so same angle with the horizontal. So let's focus on the blue triangle. Cosine theta is 5 over 5.546 centimeters. So angle theta is easily found. You can replace it in the equation below and you can find F2x per L. And you stop here because you don't need to find F2x. You just need to find F2x per unit length L. Now, Ampere's law is used to find also the magnetic field induced by a current enclosed by Ampere's loop. Ampere's loop هي الدي ال أو sorry الدي ال هي part من Ampere's loop which is usually a circle or a rectangle. In this problem, they are asking you to find the magnetic field induced by the current inside and then on and then outside the wire surface. If you are inside, you take a loop that is on the point where you are measuring the magnetic field. لأن أنتوا you have to measure magnetic field at this point, يعني at 1 centimeters. So you take the loop at 1 centimeters. So you know that the integral of EBDL since the B هي على tangent والDL هي part من الcircle so كمان هي على tangent يعني الcosine 0 is 1. So I can remove the vectors من ال BDL بصيروا integral BDL cosine 0 which is 1 equal mu 0 times ال I enclosed. هلا نحن بكل هيدي الأورنج circle أو الأورنج disk هو كلياته current بس actually I'm only interested in the current enclosed by the loop. يعني I'm only interested in the area inside the small هيدا dotted line not the whole orange one. هلا كيف بجيب الاريا اللي هي only inside ال R اللي هي باي R squared اوكي وقديش الاريا of the orange part هي باي A squared so you say انه it is pi R squared over pi A squared times I total. هلا if you take ال B outside the integral بدللكم integral of dl اللي هي 2 pi R small r. If you cancel out ال r squared مع ال r قبله بعد ال equal you will get b equals mu 0 over 2 pi r over a squared times I total. You substitute r and a by their values and you can find the b total. Now they are asking you to find the magnetic field's magnitude at the edge of the wire يعني at r equals a which is 2 centimeters on the wire surface. So you repeat the same work, but this time small r is equal to big R, and thus you will find the final answer اللي هي mu 0 I over 2 pi r. You substitute and to find the magnitude B. And finally, in part C, if you are standing 4 centimeters away from the center, yes, you replace R by 4 centimeters, but I enclosed it will always be 170 ampere. But of course, you put the distance between where you are standing, where the magnetic field is applied, where they are asking you to find the magnetic field, يعني هي 4 centimeters away from the center, and you put I total enclosed in your loop, which is I total 170 ampere.